Marine Satellite Applications webinar. Today, we're very happy to have William Churchill, at the time of this event, a meteorologist at the forecast office in Key West. Since then, he has transitioned to WPC, where he's in the forecast operations branch. But today, he's talking about something that happened in the Keys, a retrospective satellite analysis of the February 8th, 2021 Florida Keys dense sea fog event. Next slide, please. This is part of an ongoing webinar series. I'm Scott Lindstrom, and Dan Bikos and I are the coordinators of this series. We're always looking for speakers. So if you want to know, if you want to speak about a topic, if you want to volunteer yourself or someone else, let us know. We can help you create content, or you can just present what you want. Next slide, please. And it's just going to be a forecast event in your office where satellite imagery was important. Typically about 20 minutes for the speaker. You can send in questions via the GoToChat, or you can ask during the question and answer period via the phone. This should take about 30 minutes. Don't press hold and mute if you're not speaking. Take it away, William.
All right, thank you, Scott. See if I can get my presentation up here now. View. All right, so thank you for that introduction. I will not belabor the title, but this is basically just a very interesting and unusual event that happened in the Keys. So kind of just to contextualize things at first, I just want to kind of speak to how rare dense fog is in general in the Keys. And it's never really straightforward when we get it. We get it in a couple different types of ways. But just for contextualization here, a marine dense fog advisory is not even issued twice per year on average. So here's the total count per CWA since 2005, so about 16 years worth of climatology, so to speak. And you can see the Keys are actually one of the lowest, just behind Melbourne, in terms of how often these products are issued in Southern region alone. And you can see how that's compared to other offices, especially in the Northern Gulf Coast, where they issue a pretty significant number of these in comparison. Obviously, they're 250 to almost 400 in Houston. So pretty remarkable how many of them these that they issue, but we're not even at 2 per year down here in Key West. And then I'll compare that, the Marine Dense Fog Advisory has a mile criteria, where if the fog is underneath 1 statute mile, you're issuing it, or nautical mile, I think, actually, for the Marine. But when it comes to dense fog, you're only issuing that for a 1/4 mile or less visibility. And so those are even more infrequent in the Keys. You can see we have a pitiful 12 over this 16-year period, so less than 1 per year, or 0.71 to be more specific, since 2005. And that actually puts us in a relatively exclusive club of offices that issue more marine dense fog advisories than dense fog advisories. So we're one of only 6 that issue less of the land-based one than the marine. So we're actually the only one in Southern region. We're joined by Newport, Wakefield, New York, Green Bay, and Marquette when it comes to that. So you can see, on average, less than 1 per year since 2005. So not very common. So it's a little hard to predict these a lot of the time. It's not as straightforward. So we'll get into, kind of what makes the Florida Keys unique. Many things make the Florida Keys itself unique. Here's a couple pictures I've taken while I was there, actually, both in the backyard of the Weather Service office, of a bunch of iguanas up in the tree and chickens. So yes, there's plenty of those in the Keys, and part of what makes it unique. But the weather there itself is actually pretty unique in a lot of ways. So we basically exist on this natural zone of some baroclinicity there, especially during the winter months, driven by the SST gradient from the Florida Straits, where the Gulf Stream is, to the shallow Bayside and Gulf side waters, or the West Florida Shelf. So, a lot of times we get a pretty significant gradient there, and create that little natural zone of some baroclinicity. And kind of a significant aspect of the Keys is that pretty much all the weather is mesoscale driven. So, we do get some strongly forced events come through the Keys in the winter. We can get a strongly forced synoptic event, but most of the time, I like to say the Florida Keys are where cold fronts come to die. A lot of times they will drape right over us or become stationary, very close to the keys itself. And that baroclinic zone can almost act as a little bit of a magnet to bring that synoptic boundary there if it's anywhere near us. So some interesting mesoscale things can happen once you get a synoptic boundary kind of laid over the keys. So one thing to think about, whether it's a thunderstorm or the track of a hurricane or even this dense fog event, when the mesoscale is the main factor, it's going to make it often particularly hard to predict, and the hazardous weather associated with it particularly hard to predict. When you have something synoptic, models handle it better. It's more easily forecastable. It happens on a longer time scale. So everything about the mesoscale, as we well know as meteorologists, is more difficult to forecast. And you actually kind of compound that in the keys with the lack of observations, since we're 99% water, and that lack of observations kind of floods over into the cam output as well, which can be inaccurate across much of the CONUS at times, but even more so in the keys. So those are some significant aspects of what makes fog forecasting difficult in the keys, with it just being a more rare event to begin with, that also factoring in. So here's some ingredients. This is definitely not a full list. These are really just certain things you can look for that might key you into the fact that you can get some sort of fog, or some of these conditions are even good for a radiation fog, but we'll say sea fog in this case. So probably one of the main things you're going to need is to get sea fog, kind of the creation of it itself, is you want theta rich air transported over cooler water. So in our case, that's going to be transported northward over cooler water into the bayside and Gulf side waters, which are, those shallow waters are often the cold waters in the winter. So a couple of aspects there. The weather pattern configuration is obviously crucial to get that southerly transport. So you need a rich access to the east or southeast to really bring those southerly winds in to get that that more moist air transported northward. And a good rule of thumb is that the dew points associated with the warmer moist air need to be at least 4 degrees Fahrenheit higher than your SSTs to the north. Kind of a second significant thing, this is kind of the mesoscale aspect of it, is you want a weak pressure pattern nearby. So, when you're lacking synoptic features, when there's a nearby stationary front and or a call or saddle point region, when that's nearby, you have a weak pressure pattern, and it allows some of these mesoscale factors to be more pronounced. So for example, a lot of times in the winter at night, we're getting a weak pressure pattern, allowing for kind of the whispers of northerlies at night, or that driven by the SST gradient, kind of the heat-seeking wind. You basically get this natural backing of the winds at night due to that cold water. And then you kind of can get a boost from that as well, from Florida breathing out, so to speak, or the land breeze. So at night, we can, even in a post-frontal environment specifically, you can get these really impressive density gradient from the mainland coming off and really enhancing your north winds. So that can often assist with northerlies, and is a good thing to keep in mind as well. And then, just another mesoscale aspect to it. But talking about the dense fog itself, kind of the third really good thing to look out for is a good antecedent rain. So that's always a good, pre-existing condition to promote dense fog. It's always a good thing if it rains. So unlike the northern Gulf Coast, just to kind of summarize this, is that sea fog setups are usually not as straightforward and strongly forced in the Keys, and due to the fickle nature of all these mesoscale events, or kind of technicalities of it, the mesoscale aspect itself is going to limit your overall coverage and predictability. And just for this event, I call it the Florida Keys event, but it's really just the lower Keys. There's a little bit of patchy dense fog that are not even so dense, but some patchy fog even into the upper Keys, or sorry, the middle Keys. But for the most part, this was only a lower Keys event, so it just speaks to how localized the phenomenon is. So let's get into a little bit of the event itself that just kind of gets the wheels turning in your head about what you're looking for, possibly for fog in the Keys. I just wanted to talk about, the cooler waters. To have cooler waters, we kind of need a front beforehand to really cool down those waters significantly. So I just wanted to show the climatology, which is, typically on the bayside, Gulf side waters in the lower to mid 70s in February, whereas out in the Straits, you're talking more mid to upper 70s. So climatologically speaking, you have generally a 2 to 4 degree difference between the two. But here are the SSTs from that particular day, or the day after, actually, in this case, February 8th. So we had SSTs in the Gulf Bayside waters closer to 70, so a little bit cooler than climatology, and then in the Straits a little bit higher, actually closer to 80 degrees. So while normally it's a 2 to 4 degree difference, for this particular event, we were closer to a 7 to 11 degree Fahrenheit difference. So you kind of see where we're going with this already. When you want your dew points in the warmer air to be at least 4 degrees above, you know, we're kind of working with something here. And if you want to see that as expressed as an anomaly to compare to climatology, about 4 degrees cooler and 4 degrees warmer respectively. So the climatological difference from climatology itself is about 8 degrees. So here's some surface maps just to kind of give you an idea what the general surface pattern looked like. You can see we're actually pretty cool morning of Sunday, so in the mid 70s with dew points near 70. But we do during the day, as this cold front's coming towards us and getting ready to stall out, our dew points have risen into the lower to mid 70s even, and you can see that southerly flow, you know, fairly weak, but it's there across the Keys and out towards the Bahamas. And going towards 0Z, you can see our temperatures already near our dew point. You know, dew points in the low to mid 70s, temps in the mid 70s. And then by 6Z, that front is really nearby. We've only got a couple degree difference between our temperature and our dew points. So we're already close to foggy conditions there. And then you see by morning, we actually have the front itself draped right over us. And if we go into the next day, you see that front retreat northward once again. So even though it's a stationary front, you can kind of see it bouncing around on the analysis. So this is where those mesoscale factors come in. So I'll show just kind of more of an idealized plot. You can see, we'll, you know, just as an idealized plot, show this as thinking of this as the afternoon, the night before the event. You can see the southerly winds, the front to the north, the ridge axis to the east. And then at night, you see that front kind of sag south. Well, that's that mesoscale factor we were talking about, the, you know, the northerlies whispering in with the cooler waters promoting that, maybe a little bit of an effect from the mainland as well, and a small amount of density current from that. But this isn't really the full picture, just the surface maps. There's one other really significant component that we got to get to, which is the antecedent rain. And if you look at the climatological data for the last 7 days leading up to this, or the first days of February, you can see we did have a more substantial front with lows in the upper 50s for a couple of days earlier in the month. So that really is probably the main synoptic feature that set the stage for this event, was the cooling of the waters. So really just wintertime itself. And we don't always get the consistent fronts throughout the winter in Key West. But in this case, we did, you know, get those waters set up from an anomaly standpoint. But as far as the precipitation goes, if you look at the precipitation column, we're pretty much zero. We had 500ths on the first day of the month, but there really wasn't a significant heavy rainfall event leading up to it. And I went ahead and included snowfall there. You never know, February, I know it's the Keys, but it is winter. So before I get into some satellite imagery, I just wanted to go through one radar loop here, which I thought was really interesting. You can see where the front was analyzed, showing up as a line here on radar. But even though the Keys didn't get rain leading up to this event, you can see there was quite a bit of showers in the area. And in fact, we even had a thunderstorm just west of Key West right before this event. So if you look closely at the radar imagery here, you can see kind of a deviant motion there on one of the more intense cells west of Key West. So that was the thunderstorm. So we'll talk about what kind of implications that had. So even though the Keys themselves didn't get the heavy rain, there was some heavy rain nearby right before the event. And that probably played a pretty significant role. And then, yeah, towards the end of the loop there, I'll just let it play through a couple more times. You can see that that light line of reflectivity, maybe partially an outflow boundary from that thunderstorm. It originates kind of near that point, but it's looks like more of a longer feature going all the way out to the Straits. So it's probably, you know, the focusing of the front itself too, maybe enhanced a little bit as an outflow boundary and pushed southeast. So a lot of, just in this loop, I think a lot of really interesting mesoscale to even storm scale details, you know, driving these features. But I think even more helpful in this case was the satellite imagery. So the radar kind of gives you an idea what we were looking at here. But here's the nighttime microphysics RGB, and which I think is one of the most useful GOES products. So you get a lot of information condensed into this RGB. You got the fog difference channel, and basically cloud thickness information as well. So what this results in is we can see towards the beginning of this loop, the reds and yellows, that's your thunderstorm. So that's your really high cold cloud tops being depicted there in the brighter reds and yellows. So you can see that kind of dissipate and go off to the east, but then in its wake, look at all the aquas, your very low stratus and fog basically showing up there in the fog difference product. So it's really subtle, but you can see the boundary itself shows up really well, but then look to the west of it and you kind of get the easterlies and the low levels pushing the front back to the north, advecting that fog westward into the lower keys. And it's kind of forming in situ too. So it's pretty complicated what's going on here and all the little meteorological factors. So we'll kind of go from the end of this loop. So this is a nighttime only loop, the nighttime microphysics RGB. Once the sun comes up, this kind of loses its utility. But we can go to just natural color RGB here, the Sims natural color RGB from the morning of. So this is now the 8th. We're showing kind of post fog, but at the very beginning of this loop, you can see very thin fog, and that stuff is dense, even though it's thin right over the keys. Pretty quickly lifts out, but you can see it kind of lingering and remaining a problem in the coastal waters to the north and west of Key West, kind of blowing off towards the west later in the day there. So a lot of this is low stratus or very low stratus, but a lot of it's definitely making it to the ground as well. So just the soundings real quick, I wanted to show you. This is before the fog. You can see already a bit of a temperature inversion there. The temp and dew point are already not too far off from each other. And then transitioning to the morning, you can see how much steeper that inversion has gotten, and the fact that there's basically no clouds through the remainder of the atmosphere. You don't even have as much humidity there at 800 millibars. Some of the mid-level clouds that were there before, that's since scattered out, and you're basically left with just the near surface high relative humidity there. So here's the observations themselves. Just to show you, we did get below a quarter of a mile there, and it was for about a solid hour at Key West, right around sunrise, so pretty impactful time of day. The Key West airport actually doesn't even run 24 hours a day, so it's opening up in the morning, starting to get flights coming in the morning. This is post-COVID, so we didn't have the cruise ships, but that's something to consider. A lot of times in the Keys, the cruise ships coming in the morning. So you can see there, though, it's very interesting when you look at just the winds. They're east before, you can kind of see the impact of that outflow boundary / front, and then it doesn't take long for, actually before even sunrise, you lose that northerly component. We go basically dead calm, and then as soon as the easterlies come back in, that's when the fog is at its worst from the light east to southeast winds there. Here's one more perspective from Boca Chica. So this is just west of Key West, another ASOS. They had dense fog there, quarter-mile fog for almost 2 hours. And one other thing to notice, you can see it on Key West METARs as well, but you can see leading up to the fog, we already had LIFR ceilings, so we had ceilings below 500 feet even before the dense fog set in. So certainly, aviation impacts either way. Even if we didn't get the dense fog, we're still talking LIFR ceilings, which are very uncommon in Key West. You're basically only getting those in a heavy downpour. So around 3 a.m. we went with not quite the dense fog advisory yet, but for a special weather statement, with it being as unusual as it is, just specifying that the fog had reduced visibility to 1 mile or less at times, but then it got more dense, and we went with the dense fog advisory. So one of those 13 that have happened in the past 16 years I got to issue, which was definitely interesting. So, and just to talk about one other component, we looked at some of the raw satellite imagery itself, but here is a derived product, the LIFR probabilities product. And I'll be honest, I don't have a ton of experience using this product because a lot of times it's not something we have to worry about too much in the Keys. So I'm not sure how often it gives sort of false positives, or if anyone wants to speak to that. But in this case, it certainly did have a signal there. From the imagery itself, giving relatively high probabilities here, 30% plus of the LIFR at times. And I think it captures quite well too, actually, the subtleties. So we had broken out of the fog there for a little bit. So you can see in the gap in this loop that go away. The probabilities get very low for a brief time there, and we did actually briefly clear up. So it's interesting how it captured some of the subtleties of that as well, just based on the imagery. So here's some pictures real quick before we get to questions from some of the traffic cams at the mile markers, so you can see just how thick this low stratus and fog was. So this is you can see the mile markers there. So 9 miles up the Keys from Key West and 5 miles up the Keys from Key West there. And then even farther up, we had some impacts after sunrise. So a little bit of patchy fog there at 16 and 31 miles. Here's the view. This is City Hall from the roof. This is looking toward the west. So you can see the impacts there from actually our upper air shelter, which is on our roof. So that's looking out from there and then looking the opposite direction. And then probably most significantly, looking towards the airport. So this is looking pretty much east to southeast. And you can see that that's definitely the direction it looks the most dense at this particular time. But then after work, after the sun had fully come up, I also went out to just south on White Street to the White Street Pier. And this is looking toward the airport. You can see how quite dense it is. Very unusual sight in the Keys. And then looking out towards the pier. It's about 200 yards or a little under 200 yards from where I took this picture to that the point in the pier where it opens up. So, we're talking well under a quarter mile, probably about 1/10 of a mile here. And our lowest report was from the Key West Express that was coming in from Fort Myers, which called out on the radio to one of our meteorologists, Chris Rothwell, that they had confirmed 100 yards or less of horizontal visibility when they were between Marco and Northwest Channel. So I have a loop here. This is the last thing that I have that I can kind of put on for a minute here, just to give you a little bit of a fuller perspective of this. And I believe it was Scott that created this loop for me, so thank you, Scott or Dan. And you can see here that thunderstorm earlier on in the top right in the nighttime microphysics. Bottom left is just your fog difference. So that gives you a good signal too. I like how it looks better in the nighttime microphysics myself. And then you've got just pure long wave radiation on the bottom right and then pure visible on the top left. So just giving you a bunch of different perspectives of this full event. And I think it's just fascinating, the mesoscale aspects of it, the fickle nature of it all, the fact that you have these really high impacts from something that is, not nearly as solid of an event as you would get on the strongly forced cases farther up in the northern Gulf Coast. So with that, I'll present here on my last slide again. Just included something interesting here, Sand Key Light, which is about 8 miles to the southwest of Key West. And there actually used to be a Weather Bureau office there. So there's a picture from 1905 when they used to take weather observations there, and you can see more of what it looks like today, that picture I took on the bottom left. So hopefully this is an interesting case, just an interesting place and an interesting weather phenomenon. So I'll take any questions and wrap that up.
Thanks a lot. We have a couple of comments. One is that the sandbox tree is gone. I don't know if you knew that.
Yes, it is.
That's from Chip.
I got to see that hauled away.
Yeah. I have a question about you said one of the antecedents for this is heavy rain to the north. And I'm wondering if that's just, you have the heavy rain and it cools the surface of the ocean. So is it really just changing the temperature? I mean, is it one way to change? I mean, it's an easy way to change the surface temperature of the ocean is to rain on it. Is that why rain is an antecedent climatologically for fog formation in the Keys?
No, that's an interesting point. I would think actually it's more the juicing up the dew point a little bit more just from getting the moisture from the rain itself. But yeah, that could certainly also be an impact. Really, you're just trying to get as many of those conditions as possible because it's so hard to get to begin with. you're just looking out for any of these little clues you can get to hint you in on the possibility of that fog. Because, you know, this is more of a sea fog event. So this was the closest I saw to a true sea fog event. And even that, I would say, is kind of borderline marginal. What I saw more often there were our radiational fog events. And that was just from being in more of the call region in those cases, and just getting dead calm winds, clear skies. And oftentimes that fog would be so shallow that it wouldn't really even have impacts. It'd be just like near the ground layer.
Right.
But could get particularly dense. So that's just another interesting case. But this is, you know, more of the true, like almost very low stratus becoming fog.
Yeah, I thought the analysis of the climatological temperatures in the current and in the shelf water was really interesting, and I'm kind of wondering if a forecaster going into the office under those conditions is aware that, oh, this is, you know, this might be a very rare event of fog because we have the forcing mechanisms for the sea surface temperature differences. So on this particular day, was there chatter in the office the day beforehand, there might be fog tonight? Is it something, because it's a rare event and there's an awareness that happens?
No, definitely. I think, you know, what we're often talking about when it comes to forecasting there is if we are getting these strong cold fronts. So your Gulf Stream is pretty much always warm, and maybe some of that, you know, I'm not exactly sure where the positive anomaly was coming from in the Gulf Stream. But I know the negative anomaly in the cooler waters is certainly tied to the stronger fronts. So anytime we're getting those stronger fronts coming through, we're getting significant cooling of those waters. And so anytime that happens and we get a weather configuration that's going to, you know, quickly switch back to the southerly flow, that, you know, we're pretty much always keyed into the fact that there could be some fog. You know, oftentimes it doesn't materialize, but I was only there 2.5 years, so I'd certainly heard stories of you know, more pronounced events than this in the past, where you have even cooler waters and a more strongly forced, you know, southerly flow.
Right.
So this is kind of just one of those more marginal cases, I think.
I like how you said you were keyed into it. I don't want to ask all the questions. I don't see any other questions in the chat box, but if anyone has a question, feel free to unmute and ask that question. Okay, I don't see anyone unmuting, so I'm going to extend my deep gratitude to William for talking today. It's always interesting to hear about the weather in different forecast offices for me. So that is the end of this particular FDTD Satellite Applications webinar. There will be another one on September 8th. Dora Meredith from a forecast office that is farther south than Key West will be talking about using satellite data to forecast heavy rain, and that is in American Samoa. So thanks again, William.
Thanks, Scott.